Alright, part B, we want to write the first four non-zero terms of the Maclaurin series for f prime, the derivative of f, and express that as a rational function, or express f prime, not this Maclaurin polynomial. So in here, they only give me the first three terms. I need four, so I can't just use this little cheaty thing here. I could evaluate the fourth term there, but it's probably best to just say, okay, if the nth term of this is going to be here, then the nth term of f prime is basically the derivative of this, which is going to be this here. We have -3 to the n minus 1 over n times, and let's do power function rule, n x to the n minus 1, which gives me -3 to the n minus 1 times x to the n minus 1, or -3x all to the n minus 1. Okay, and now we can see that f prime of x will equal the sum of all these terms from 1 to infinity. So -3x to the n minus 1. And this sort of first four terms are going to be put in 1. We get n minus 1 is 0. Anything to the 0 power is 1. Or anything that's not 0 to the 0 power is 1. Put in 2. 2 minus 1 is 1. -3x to the first is -3x. Put in 3. 3 minus 1 is 2. -3x to the second is 9x squared. And then put in 4. 4 minus 1 is 3. -3x to the third is going to be -27x to the third. And it keeps going, but those are the first three non-zero terms. And you can see, of course, if I do the derivative of this, I get 1. Derivative of this, I get -3x. Derivative of this, I get 9x squared. And I get the next term there. Okay, now I want to represent or express this as a rational function. And at least when I'm teaching the Maclaurin series, pretty much the first example, sort of an infinite series, is where I consider this, so this is a little aside to the problem, where I consider the fraction 1 over 1 minus some number times x. And if I do the long division on this, so I have 1, put the 1 minus ax out here, and then 1 goes into 1 one time. I multiply through 1 minus ax. I subtract that and get ax. And then 1 goes into ax times. Multiply back down, I get ax minus a squared x squared, and subtract that. And so just doing long division here, I get to this pattern. 1 goes into a squared x squared times, and we see this pattern, same type of pattern that we have right here. So I just sort of recognize this pattern, and in this case, a is -3, because I sort of have -3 to the 0 first, second, third, so I know from that f prime of x is equal to 1 over 1 minus -3x, which is the same thing as 1 over 1 plus 3x.